Capacitance of parallel plate capacitor. Hi. In this video, we are going to find out the capacitance of parallel plate capacitors. In the previous video, we saw what does parallel plate capacitor looks like. If you have not seen it, make sure you watch it. Let's start. Let's say we have a parallel plate capacitor. The area of the plates is A. The distance between the plates is D. And one plate of the capacitor is plus Q charged, and the other plate is minus Q charged. Now due to two plates, there will be two electric fields. One because of the plus Q plate, and the other due to the minus Q plate. And the direction of both the fields will be the same. Let's say one electric field is E1, and the other one is E2. We have learned from the previous videos that due to infinite plate, the electric field is equal to sigma by 2 epsilon, where sigma is the total charge per unit area. Therefore, E1 and E2 is equal to sigma by 2 epsilon. We get a total electric field by adding the two electric fields. E is equal to sigma by 2 epsilon plus sigma by 2 epsilon, which is equal to sigma by epsilon. Putting the value of sigma, we get E is equal to Q by A into epsilon. Now according to the definition of potential difference, we have V is equal to E into D. V is equal to Q into D by A into epsilon. Now we know that C is equal to Q by V. Putting the value of V from above, we get C is equal to Q by Q into D by A into epsilon. Q cancels each other, and we get C is equal to epsilon into A by D. Again, through the formula, we have proof that capacitance doesn't depend on charge and voltage, but on the medium and dimension of the capacitor. This is it for today's video. Let us know in the comments section which topic you want to see next. Before leaving, check the exclusive offers, link in the description below. And do not forget to hit the like and subscribe button. To find out more on the subject, continue watching the next video.